Okay, but I'm going to write this down, so this is just the first problem. So is this function odd, even, or none of the above? It would have been even if this were an arrow.
Yeah.
But this one ends here and over there continues forever. So it's deceiving. Be very careful. The function is not symmetric. It's not odd. It's not even. F of 2. Is f of 2 a relative max? F of 2, in your book, and I can show you the calculus book, they contradict each other. In your book, this value, this point, is not considered maximum. In calculus book, is considered maximum. Because this side, they consider that both sides have to be smaller, not equal to. If these both sides are smaller than that point, that is maximum. But since it's like this, and this side is not smaller like this would have been a maximum according to this book. This is not a maximum, although the calculus book says it is. So let's go with this and say no, it's not a maximum. It's not a relative max. Okay, so now let's write all these answers. What am I doing? Okay. So in part A, the domain was -infinity 4. In part B, the range was -infinity 1.
I thought the first one was -infinity 6.
Oh, 6, of course. Why did I write 4? I'm not sure. Sorry about that. The zeros, -3, 0, and 3, 0. F of 0. F of 0 is 1. The point is 0, 1. Y-intercept. Intervals, here's how I write f increasing on the interval -infinity, -2. F decreasing on 2, 6. G. F constant on the interval -2, 2. It's a very good point. This is not an ordered pair. This is not an ordered pair. Right? It's an interval. That's why I put on. This is not x, y. This is only for x. H. Values of x for which f of x is greater than 0. We said between -3 and 3. On the interval -3, 3. I. We said f of x was -2, and we determined x equals 5 or -5. You can present the point 5, -2, and -5, -2 as well. J, f of 4, it was negative. K, not symmetric, which means it's not even and it's not odd. And the last one, they, according to this book, f of 2 is not a relative max. How are we doing with this kind of problem? How do we feel about this kind of problem? Are we okay? Is this okay? I couldn't hear. I'm sorry. I was.
What did you want?
Sure. So please choose one.
Do 50.
Okay, we want to look at 50. Is this okay, everyone? Okay, so let's look at the graph. And let's answer the domain, please. What is the domain of this function? Can you see, everyone? -infinity to, correct. Range. Range is from the lowest y value to the largest y value.
You're right. -infinity to infinity. No, you said y. I'm sorry.
So the highest value is 4. So -infinity to 4. with a bracket at 4. X-intercepts, please. Negative 4 comma 0, 4 comma 0. Agreed? Y-intercept. 0 comma 1. 0 comma 1 is the y-intercept. Intervals on which f is increasing. Now you see, look at my hand or the trend. This is the trend. Maximum, increasing minimum, increasing maximum, decreasing. So on this interval and this interval, the function is increasing. So between negative infinity and negative 2, union between 1 and 3, the function's trend is increasing. So
show it one more time.
Yeah, just follow the graph.
Okay.
Increasing, decreasing, increasing, decreasing.
And it's like all those points.
No, the trend, like the range of between 2000 and 2010, somebody's salary increased. We don't care from which value to which value. We are only interested in for which interval the function is increasing. One more time. From negative infinity till negative 2, the trend is increasing. Union between 1 and 3, the trend is increasing.
Okay. Negative.
See my hand?
Is it increase?
So it's increasing between negative infinity and negative 2. Then it's decreasing between negative 2 and 0. Then it's increasing between 1 and 3. And then it's decreasing from 3 to infinity. We do not look at the points where it's a maximum or a minimum. We're identifying the trend. So when you tell someone, my salary increased between 2000 and 2010, you're not telling them from which value to which value. We're not interested from which value to which value. You just say, my salary increased from the year 2000 to the year 2010. That's all we are establishing here.
And it says negative infinity. What? 2?
Yes, that's where it has a turn.
Okay.
That's exactly where it turns from increasing to decreasing.
Got it.
Yeah. So let's write it down. F increasing from negative infinity to negative 2. Union from 1 to 3. They're all open parentheses, not brackets, nothing. The function is decreasing on the interval negative 2 to 0, union 3 to infinity. Is that clear? Do we understand? Do we understand this concept?
Decrease in negative 2 to 0.
Yes.
Looking at the x-axis.
We are only looking at the x-axis. Is that clear?
Yeah, because that's where it first decreases that, right? That's the very first one.
Yeah. Do we understand this concept or not? Please say yes or no. Yes, Ella, is this clear?
Yeah.
So one more time. Between negative infinity and negative 2, I don't care where it's going, but I see it's increasing. Between negative infinity and negative 2. The next piece, from negative 2 to 0, the function is decreasing. The next piece, from 0 to 3, what does it do? That's it. And from 3 to infinity, what does it do? That's it. We don't care from which value till which value. You're just telling someone my salary increased. Not from 100,000 to 300,000, but from the year 2000 to the year 2010. Just when the trend happened. Okay. Values of x for which f of x is less than or equal to 0. For which x values is this function negative? Yes? For which x values, the same thing, the same question is the trend here. So for which x values is the function negative or zero?
-4.
Okay, one more time. Function is below the x-axis. What type of number would this be? What type of number is the function value when the graph is below the x-axis? Correct. So what type of value is the function or the y value when the graph is above the x-axis? What type of value will again have the function if its graph is below the x-axis? So now the question is for which x values is the function negative? Negative infinity to -4, union
4 to -2 to infinity.
Exactly. Awesome. Very good. The numbers at which f has a relative max. So let's talk about this for a moment. When I'm asked, does this function have a relative max? I'll say yes. If I'm asked, give me the location, where is it? I will say at x equals -2 is one, and at x equals 3 is the other. But now the second question is, how much is it? How much is the maximum? I'm asked to determine the y value. So where is it is the position of the minimum or maximum at -2. Where else? At 3. How much is the first maximum? 4. How much is the second maximum? 2. So 2 questions for the same point. Where means position. How much means the y value, altitude. It's like saying, where is Mount Everest? Location. How tall is it? Maximum. So the numbers at which f has a relative max, please write x equals -2 and x equals 3. The relative max of f is 2 for x equals 3 and 4 for x equals -2. So the x values are -2 and 3. Now the next question is asking us, what is the maximum? I'll say for the first one, the maximum is 4. For the second one, for x equals 3, the maximum is 2. F of -2. Can anyone give us f of -2 and what we need to do? How do I find it? What is given to us? F of -2 means x equals -2. X equals -2, and I read the y value. How much? 4. F of -2 is 4. The values of x for which f of x is 0. Same question with before, right? What are they called? The x-intercepts, or the zeros of the function. Same question, same answer. A different way of writing, of saying it. So -4 and 4. Final question. Is the function odd, even, or not symmetric? Of course, it's not symmetric. A graph that is even will have the exact same copy on this side as well as on that side. This peak is at 3, at 3 and 2, and that is at -2 and 4. Not symmetric. Okay, let me write this down for you. Here's what we have. And this was 50. Part A, we had -infinity to infinity. That's the domain. Part B, the range was -infinity to 4. Oh, yes, of course. I'm sorry. I'm sorry. Sorry about that. So domain -infinity to infinity, range -infinity to 4. What was that? C, x-intercepts, -4, 0, and 4, 0. X-intercepts or zeros of f of x. By the way, this problem doesn't ask us, but I'm asking you, is this a function or not? By the vertical line test is a function. Very good. Y-intercept d 0, 1. Interval on which f is increasing. F is increasing on the interval -∞ to -2, union 0, 3. Is this function constant? No. -2, 0, union 3, infinity. Interval values of x for which f of x is less than or equal to 0. F of x less than or equal to 0 is between -∞ on the interval -∞ to what was that? -∞ to -4 with a bracket. Why? Because of the equal symbol here. Union bracket 4 to infinity. The numbers at which f of x has a relative max. Relative max found at x equals -2 and at x equals 3. Find the relative max. The relative max is the y value. So I will write f of -2 and f of 3. And you told me f of -2, where was it? -2 was 4, and this was 2. So when I'm asked to find the relative max, I'm asked to find the y value. When I'm asked to find where or the values of x, I'm asked the position. You said f of -2 equals 4. This is the same question in J. K is the same question. F of x equals 0. We have them right here, -4 and 4. X equals -4 and x equals 4. And the last one, L not, function is not symmetric. It's not odd, it's not even. Any questions? Any questions? Okay, I would like us to identify whether a function is odd, even, or none of the above. So on this handout, please choose any function you would like. In 2.2, let's choose a function and identify, it says use algebra to determine whether the following functions are odd, even, or none of the above. However, you can also choose from your book, from page 250. It's up to you. And problems are 37 through 48. But please choose one. From the handout? Yes. Very good. So here it is. We have f of x, which is 3x divided by x squared minus 5. Perfect fit. Okay, let me refresh our memory first of what we're trying to do and what are the options. If you remember from last time, we came up with two relationships. A function is odd if f of -x equals, and you'll tell me what it is, and a function is even if f of -x equals something else. Anyone remembers what those are? You may have them in your notes from last time. Correct. Very good. Awesome. And the other one if it's the same. So this is what we need to test. Can a function be odd and even at the same time? There's only one function, but the function that nobody cares about. It's y equals 0. Just the x-axis. But who cares about a function f of x equals 0? No one. This is the only function that is symmetric with respect to the origin and symmetric with respect to the y-axis. So once I establish that the function is odd, obviously it cannot be even. If I establish that it's even, it cannot be odd. If it's neither, then it's not symmetric. Notice what is important here and what is the common piece. This is the common piece. This is my starting point, therefore. I need to find f of negative x. So can anyone tell us what this means? It's identical with saying find f of 5. So how will you find f of 5? 3 times 5, no. 3 times 5 over 5 squared minus 5. How will you find f of 2? 3 times 2 over 2 squared minus 5. How will you find f of 15? 3 times 15 over 15 squared minus 5, and I can go on forever. But I want to determine f of negative x in the same way. So please tell me what to write. 3 times negative x, very good, over, but it has to be in parentheses, minus 5. Awesome. Thank you, Rachel. So now I perform and simplify to the most. How much is 3 times negative x?
Negative.
Very good. How much is negative x squared?
X.
Squared, minus 5. Remember what we do with the minus, either from the top or from the bottom. In this case, from the top. I can put it in front. And I should put it in front, right? No, we don't write negative 2 over 5. We write negative 2/5, correct? We agree? So that's why I put a minus in front. So now I have 3 questions to ask myself, and only one of these 3 has the answer yes. The other 2 must have the answer no. Does this equal the identical function? I'm going to copy it here. Does this equal the opposite of the function? I'm going to copy it here. Or none of the above. So, f of negative x, is it identical with the original function?
No.
No. Cross it out. So then the function is not even so far, if it's not the same. Does this simplified form equal, is identical with the opposite of the function, which is this?
Yes.
I will say the function is odd. Cross out everything else. Therefore, the function, when we get a chance to graph it in chapter 3, we will graph a function that will be symmetric with respect to the origin. Will be a function symmetric with the origin. Any questions? Yes.
What? So how did it become negative again?
Which portion?
The bottom, right? The bottom. Yeah.
This one?
Mm-hmm.
Negative 2 over 5 is negative 2/5. Negative 3x over something is negative 3x over that. For the same reason. I cannot leave the negative. If I had this, do not change anything. Then I would have not been able to do that. I would have had to pull it out from both.
Right.
But in this case, I have one factor. I mean, I should say just one term with 1, 2, 3 factors, and I can take negative 1 in front. Is that better?
Mm-hmm.
Okay, so let's look at one more. Let's say 42 from your book, 250. And we have h of x equals 2x squared plus x to the 4th. Good. We're asked the same question without graphing. Is this odd, even, or none of the above? What do I have to determine? Every time I'm asked that question, I have to start by determining what? What am I determining?
What f of x would negative f of x equals the odds are even with.
What do I have to determine first? I cannot compare yet. I have to determine something first. Go back to the previous example and tell me what we found in the previous example. Age of negative x. Excellent. I can compare if I don't have the quantity first. Good. So can anyone dictate what to write? Thank you very much. Excellent. Good. So now I have to identify what is negative x squared. What does it equal to? Very good. Good. So only now I can ask myself 3 questions. Does this equal the identical function, which is 2x squared plus x to the 4th? Does this equal the opposite of the function, which obviously is negative 2x squared minus 4x to the 4th? Not 4. Why? How did I come up with that 4? Sorry. Or none of the above? It is even. Yes. Because this quantity is identical with the original function, nothing else matters, the function is even. If the first and the second do not happen, what would you conclude about the function? It's not symmetric. Its graph will not be symmetric with respect to the y-axis, and it will not be symmetric with respect to the origin. Very good. Okay, next step. We have to look at how to graph a piecewise defined function. Piecewise, W-I-S-E. Sorry about that. I stand and I might no excuse. But once I stand, I write. It's not the same. I'm sorry. Piecewise, W-I-S-E, piecewise defined function. Okay, can anyone give us an example of a piecewise defined function? Okay, here's an example. I do have a little phone as a backup because every time this phone updates and stuff like that, if it's an emergency, it's a phone that I bought it for $9 and I pay $25 per month. But if I want a different plan, this is for 1,000 minutes. I'm making the rest up because I'm paying for the smallest amount. If I want 2,000 minutes, then I will pay 35. If I want 4,000 minutes and unlimited data, blah, 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 then I'll pay 50. If I want more, I pay more. That's a piecewise defined function. For x between 0 and 1,000, 25 bucks. Between 1,000 minutes and 2,000 minutes, 35 bucks. Between 3,000 minutes and 5,000 minutes, 50 bucks. This is a piecewise defined function. Another example. I don't know anything about the new tax code, but I'm making numbers up about the old one. For somebody making between $0 and $20,000, 0 tax. Between 20,000 and 50, 10%. Between 50,000 and 100,000, 20%. Between 100,000 and 200,000, 55%. That's a piecewise defined function. A different function for different pieces of x or x axis. Okay? So here's an example. We're asked to graph it. Please choose, if you'd like, from 59 through 70. On page 252.
Can you also write down the definition for it?
Oh, you're going to see an example. There is no particular definition. It's a function defined in pieces. It can be 2 pieces, it can be 3 pieces, it can be infinitely many pieces. It can be a step function. 63 it is. 63. Perfect. 63. So we have f of x equals x plus 3, x minus 3. The first one is for if x less than negative 2, and for if x greater than to negative 2. How many pieces does this function have? This plan, for example, has like, I don't know, 4 or 5 pieces and unlimited after whatever. I don't know how many thousands of minutes. Right? How many pieces does this function have? 2 pieces. Now, you understand that somebody who makes between $0 and $20,000 cannot pay 0 and also 10%. It's 0. And between 10,000, 20,000 and 50,000, the function or the y value is whatever. It cannot be this and this. So the graph of this function cannot overlap. when I graph that piece, it cannot overlap with this piece because then it's not going to be a function anymore by the vertical line test. So be very careful with that. Okay, what do we have to determine every time we graph a function? We're asked to graph a function. What is the first thought, the first concern I have? Always. I have to find the, I will do that too, but the first step. So when I bought this plan, what did I ask first, other than how much it is?
What kind?
How many minutes I have?
Right.
Well, that's the domain. Okay. So for any time I am asked to graph a function or analyze a function or whatever, the first step is domain. Mandatory domain, first step. Okay, so now I'm going to look at this. Do not cross it out. I'm making a point. And please tell me in interval notation, what does this represent?
Negative infinity, -2.
Awesome. Again, it's more useful to present in this in interval notation.
Well, that negative infinity. 2.
Greater than or equal to -2 to infinity. So now let's analyze this piece and come up with the domain of this function. We are talking about not pieces. We are talking about the domain of this function that has 2 pieces.
So it's going to be negative infinity to infinity.
Excellent. Great job. Negative infinity to infinity, indeed. Everything is there, nothing is missing. Perfect. Okay. The next step, please create the table with me. So here it is. X values and Y values. You already told me that the domain is negative infinity to infinity. Awesome. Now let's look at the values. Let's look at the values that we have. The X values, anywhere between negative and infinity. But which is the X value that is so important that I cannot omit? And you will say 0. 0 has to be in the table no matter what. But what is the other X value that is so important that I would see at that point, I will see the function changing from this to this? What X value is that? Of course. -2 is very important. So -2 and 0 must be in the table. 0 always, in this case, -2. -2, you understand, is like the threshold. So you do whatever, 1,000 minutes, but after 1,000 minutes is a different function because you pay differently. So between 0 and 1,000, I pay $25. But if I want to up the plan beyond 1,000 minutes, then I'll pay 35 or whatever it is. Okay, or 40. Okay, so now you see at -2, I see an open parenthesis towards the left and a bracket towards the right. Right under -2, I will have these 2 symbols touching one another. I'm sure you're asking yourselves, what is she doing and what is this? In a moment, I'll explain. You'll see, it will be self-explanatory in a minute. Then I'm going to ask you, and although you'll say, but this is redundant, what you're asking me to do now, there is no need. And I will say there is a need, and I'll explain why. So I'm going to ask you for this set of X values, which function do I use? Do I use the top or the bottom? And you can say, but this is a silly question. And I would say, not really. Because sometimes the function may not be given to you, the pieces may not be given to you in the correct order. So you should be able to identify and put it right on top of the table. Why? Because then you may by mistake plug in the opposite function. So write it so you see it in front of you. So for the X values between -infinity and -2, which function will I use?
X -2.
Yeah.
Right. Oh, it's +2.
So that's why I want to put it here. So between -infinity and -2, which function do I use?
X +3.
Good. It's safer if it's up here on top of the X values. I know you know the answer, but from -2 to infinity, which function do I use? Okay, very good. Perfect. So please put it in so you don't have to go back to the function. Okay. What type of function is x plus 3? See it. What type of function is it? Is it quadratic? Is it radical? Is it rational? Linear. Linear, of course, of course. That's what I said. Say it louder. Okay, so then how many points I need for a line? Exactly 2. I can determine more, but minimum 2, right? So let's say -3. Please plug in -3 and give me the answer here. Very good. Please plug in -2 and give me the answer. I will put it inside the parenthesis. And no one said to me, wait a minute, I'm not allowed to plug in -2 in that branch. No one said that, right? But am I allowed to plug in -2 in that? Am I? I'm not.
No.
But if I don't plug in -2 and keep it as an open point, then I will have to plug in -2.000000000000000000001. Instead, I make it easy on myself. I will plug in -2 and I will leave it open. Open point. Okay, -2 on this side. What do I get? Inside the bracket, -5. Plug in 0, please. Very good. You understand that this point will be closed or open. Why? Because of the parenthesis. And you understand that this point will be closed or open. Full point or open point? Yes, because it's a bracket. That's the use of the parenthesis and the bracket. It tells me that this is an open point and this will be a closed point. Now, what if I get 1 here and 1 here? Not 1 and -5, but let's say -5 and -5, or if the two numbers are the same, or 1 and 1. What will happen there? On one side, I have an open point, but then I have to come in and fill it in. It's not going to be a gap or a jump, I should say, but one ends at 1, and the other one comes in at 1. But in this case, one has 1 with a open point, and the other one full point and -5 on the same x equals -2. Will look like this. I don't know size, whatever, but at -2, -5, and 1. Clear? Okay, so let's graph it now. First ordered pair from left to right, what will you say? Very good. 1, 2, 3. -3, 0. Next ordered pair. Very good. What type of point will that be? Very good. Connect and extend. Only to the left. If you extend to the right, you're going into the other territory. Remember my $25? I cannot extend it to the left. I would have to pay more. Okay. Next ordered pair, please. Oh, I made an error here. I'm sorry. It was on top of -2. My apologies. I went to -1. I'm sorry. -2, 1. Sorry about that.
What are we talking about right here again? It's the
-3, 0 is this point. -2, 1 is this point. -2, -5 is this point. And 0, -3 is this point. And of course, I should determine this point as well at 3. At 3 is 0. No. I don't recommend the method in the book. It's way more difficult. And you're not going to be able to put them together. This is the first example. At the second example, you're going to feel much better. Yes?
That second point on the line that you just did, what was it?
This one here?
-2. No, the second one on the or third.
0, -3.
Okay, the one right below it, the last one.
-2, -5.
Oh, okay.
-2, -5. Okay, let's choose another. And can anyone give us the range of this function? This goes on forever. This goes on forever. Very good. Okay. Once we do the second example, it will click. Very easy. Okay, so let's look at, we can choose something with quadratic, but I would like to review the quadratics in chapter 3 before we do any quadratics. But if you want to choose with quadratics, I'm fine. Or we can choose 62. So we have f of x equals 1/2 x for x less than or equal to 0, and it's 3 for x greater than 0. Let me tell me how you feel after the second one. Like before, I have to determine what first. Exactly, the domain. Very good. So replace this with an interval notation for me, please.
Negative, no.
So less than or equal to 0 from left to right, negative infinity to 0. Do we all agree with this one? Yes?
Yes.
Okay, what about the second one? What would you say about the second one?
0.
Very good. So now looking at this, these two, what would you say about the domain? You agree? It's all real numbers? You have everything to the left of 0, you have 0, and you have everything to the right of 0. Would you agree with negative infinity to infinity? Yes? Okay, perfect. So now, let's continue with the table. Which x value must be in the table? Always 0. And which value for this particular function? 0. It happens that it changes at 0. Good. See the bracket to the left. See the parenthesis to the right. Both of them under 0. And they're touching. So I've seen it in some papers, students write 0 here, and they put a bracket here and a parenthesis here. No, 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 no. So please notice exactly under 0. I think it's too much light in here. Oh, I mean that. Is this better? Okay, so see the bracket and the parenthesis. They are touching and they're exactly under 0. Which function do we use for the first piece? That's it, 1/2 x. Which function we use for the second piece? Exactly 3. Good, so give me a value here that I can divide by 2 and another value here. Any number that I can divide by 2 to the left? No, 4 is not on the left of 0.
On the left. -4.
-4 indeed. So please plug it in and give me the answer. Be very careful. That makes a point, right?
Yeah.
So to the left of 0, I have to pick numbers to the left of 0, and because otherwise I will not be able to graph. So then -4, -2, awesome. And now I have to plug in 0. Can I plug in 0 in the left? Yes, because of the bracket. No discussion there. So let's plug in 0. What do we get? 0. But can I plug in 0 on the right? No, but I'm forcing it instead of plugging in 0.0000000001. I cannot start at 1. I will be missing infinitely many real numbers. Between 0 and 1, we don't have enough life to name those numbers. Between 0 and 1, we can never finish. So let's plug in 0. How much do we get? When x is 0, y is 3. When x is 1, how much is y? Any number to the right-hand side of 0. Like I picked here, -4. I have to pick something. I cannot just use one point to graph. It's a line, so I need at least 2 points. So when x is 1, how much is y?
3.
Good. When x is 2, how much is y?
6.
But there is no x.
So
So for any x value, y is 3.
3.
That's why I was trying to make a point. When x is 3, how much is y?
3.
That's it. We can't change that. There is no x to plug in, which means it's a horizontal line at that point. Okay, so very good. So please dictate from left to right the first ordered pair. You said negative. You said negative. One more time. Every point is x comma y. Good. So -4, -2. Next point, please. Good. Is this a full point or an open point? Excellent. You cannot extend to the right. We only graph the left branch. On the other side, please dictate the first ordered pair. What type of point? Very good. Dictate another point. Very good. X is 1, y is 3. So this is the graph of the piecewise defined function given to us. Please notice that the blue graph cannot be extended to the right. Please notice that the pink, or whatever color that is, it cannot be extended to the left. If you make the error to extend the pink to the left or the blue to the right, it's no longer a function. By the vertical line test, it will not be a function. Always think of this silly little example. Between 0 and 1,000, a particular value. Between 1,000 and 2,000, a different value. Between 2,000 and 4,000 minutes, different value. Different function, in other words. Ella, is this better? Yeah. Of course. I knew it. Yes.
Why do we switch the signs again to brackets? Like, why is it a bracket and
I copied the bracket here, and I copied the parenthesis here. Say it again.
Okay. Because I'm looking at the first one that we did.
It's a different one. The signs are different for the first one.